Hello everyone, welcome back to our YouTube channel. Myself, I'm Srikanth from Smart Interviews. Today we are back with another contest, Codechef contest, which is Starters 150. So we'll quickly start with the first question. Okay, the first question says that IOI 2024 is being held in Egypt starting from 1st of September and ending on 8th of September. Given a date X, output yes if IOI is ongoing, otherwise no. Okay, as it's the first problem, it is very simple, straightforward. All you have to do is just read an integer. Even this is not necessary. Hmm. This is basically the template that I use. We have to read an integer, and if this n is greater than or equal to 1, and again the value of n must be lesser than or equal to 8 in order to print yes, right? So I'll simply print yes if this is the case, else I'll simply print no. That's it. Okay, we'll run the code. Okay, we'll submit. That's all about the first question. We'll move on to the next one. Okay, we'll start with the second question now. Here, you're given two positive integers x and y. In one operation, you can change the value of one of the integers by 1 by plus 1 or minus 1. Find the minimum number of operations needed to ensure that either x greater than or equal to 2y or y greater than or equal to 2x. Either x is at least twice as large as y or y is at least twice as large as x. Okay. You will be given t number of test cases. In the next t lines, you will be given two separate spaced integers which are x and y. Okay, fine. Okay, even this is straightforward. Even the constraints are small. Now, the thing here is, we'll consider an example which is 4 comma 4. Okay, we'll consider 4 comma 4. Our ultimate goal is to ensure either of it reaches 8. Only then we'll meet a condition where x is greater than or equal to 2y or y is greater than or equal to 2x. Okay, for that reason, we have to make any one of the value to be 8. Okay, or there are multiple ways of doing it. I'll explain you. See, one way is to make it 8. How can we get it 8? Pick this number, make it 5, make it 6, make it 7, make it 8. It took 4 operations. Okay, it took 4 operations. Okay, now either ways you can keep this as is, and you can keep updating this with 5, with 6, with 7, with 8. Okay, which took 4 operations. Okay, now we'll look at the sample IO. For the test case 4 comma 4, what was the output? It gave us 2. Okay, but the thing here is, as mentioned in the question, we did the same thing, but we got the wrong output. Why is that so? Yes, we're not supposed to only increase. We can even decrease one of the numbers to satisfy this condition. To satisfy this condition, we can either increase or we can either decrease. Okay, so we'll pick the number, we'll consider the same numbers. As of now, the answer is 4. The minimum the minimum number of operations to satisfy this condition is 4. Okay, we'll see the alternative ways. We can decrease this to 1, which gives us 3 4. We can decrease it again, which gives us 2 4. Now this is now satisfying the condition with this. So how many operations we did so far? 2. So we'll update the answer with 2. Okay, what's the other way of approaching the same? Instead of decreasing this, you can either decrease this. 3, 2. Now again, it is satisfying the condition where one of the number is at least as twice as other number. Okay. Now, even for this, we got 2 operations. We have basically checked all the 4 possibilities that we can do. That's what we did, right? So even for this, answer is 2. So the answer will not get updated as of now. So all we have to return is 2, which is the expected. Okay. So very simply, all you have to do is check all 4 possibilities. It's a most simplest solution. Okay. So I'll just write the pseudocode here. What are we going to do? Let's say we are calling a function solve. We are calling a function solve. Where it will return you the minimum number of operations, and let's say solve of x comma y. Okay, now what this solve function will do, it will count the number of operations that we did so far to make x is at least twice as y or y is at least twice as x. Okay, now we'll try to make this part while not x greater than or equal to 2y and okay, while not x greater than or equal to 2y and not y greater than or equal to 2x, what do we do? As long as this condition is true, what do we do? We'll keep on incrementing x and also increment the count. Okay, now the moment we terminate the while loop, you can just return the count. So this is one case which we discussed here. Okay, this is one case where it is 4 comma 4 and you are incrementing 4 and you're just incrementing 4, which gave you the updated value as 8, which is twice as this, and you are returning the count, which is 4. The operations that you made is 4. Instead, um, let's just as x and y max value is 10 as mentioned in the question, as x and y max value is 10. um, Even if we have something like 10 comma 10, the maximum answer is 5. It is because one of the number will be reduced to 5 and the number of operations to come till 5 is 5. Okay, so we'll just consider some answer as 10. Okay, now answer equal to minimum of answer comma solve of x comma y. Okay, this time we are incrementing x. Now, in the another turn, we'll try to increase y. Answer equal to minimum of answer comma solve function of y comma x this time. This time we are passing the parameters y comma x. Now the thing is, do we get the minimum operations only by adding? Obviously no. That part we discussed as well. So what do? We should also check with decrementing the value x here. How can we do that? How can we do that? Let's say the previous function has solve1 and the current one where we decrement is solve2 and you decrement it. That's it. As simple as that. So what do you do here? Answer equal to minimum of answer comma solve. This time we are having some solve2 function where in solve1 we keep on incrementing, whereas in solve2 we keep on decrementing the value of x. Solve2 of x comma y. And again, alternatively, what do? You'll decrement y. For that, you'll pass solve2 of y comma x. That's it. And then at the end, you'll just print the answer. So I hope you understood the logic. We are basically checking all the possibilities where once incrementing x, where once incrementing y, where once decrementing x, where once decrementing y. Okay, this thing we are doing. And obviously, as per the constraint, the brute force solution also works. Okay, now pause the screen, code it up, and come back to the video again. Okay, okay, we'll start coding it up. First, we have to read the input for range of input. We have to loop our number of test cases and then read two integers x and y. X comma y equal to map of int comma input dot split. Okay. Now we'll just assume some answer equal to some 100. Now we can also initialize it with int max. Anything is fine. Okay. Now we'll update the answer with minimum of answer comma some solve one function of x comma y. We'll just copy this, paste, paste, paste. Now here you have to pass y comma x, and again here solve2 function you will pass x comma y, again solve2 function y comma x. That's it. After this, just print the answer. Okay. Now all we have to deal is only with the solve function. Now we'll write the solve function, solve1 function x comma y. Now what do? We'll initialize some count equal to 0, and now while the condition is not met, while not, what's the condition? X greater than or equal to 2y, x greater than or equal to 2 into y. As long as this is the case, and also this is the case, y greater than or equal to 2x, what do? Simply increment the count and also do x plus plus and also y plus plus, that way. Okay, we can consider anything, y plus equal to 1 or x plus equal to 1, anything will work. Okay. Okay, now at the end you'll just return the count. Now what about the solve2 function? You will define solve2 of x comma y, and then you'll initialize count to 0. As long as this is the case that you are having, you will simply do this and x minus equal to 1. That's it. We'll run. Okay, we'll submit. Yeah, that's it. Okay, we'll move to the next question. Okay, we'll start with the third one, which is find multiset state. So we'll be given an integer array A, which is of size n, and additionally we are also given an integer k. Okay, and also A is sorted. Basically, it's a we are having some ascending data, no, ascending order data, and now uh, repeat the following three-step operation for k times. Okay, what are we doing in that? We have to find some minimum element in A, maximum element in A. Let's say those numbers are x and y. And from that, we have to delete that x, we have to delete that y. And if there exists multiple occurrences, delete only one. Okay. And append x plus y to the back of A. Okay. Huh. Okay, for example, if I have if I have 1 1 2 3 as I mentioned, as they mentioned there, and if okay, if k equal to 1, what do we do? The minimum is obviously here, maximum is obviously here. What's the reason? Given array is in a sorted order. If they give us a sorted order data, definitely first element will be the minimum element and last element will definitely be the maximum element. Okay, 1 and 3. We have to remove this 1 and 3. We have to remove that. Okay, we'll remove it. And then, sorry. Hmm, huh. And then we have to add it, which is 4, and add it back to the array, which is 1 to 4 now. Again, if I got another k, I have to remove this, I have to remove this. 1 and 4, 1 plus 4 is 5. So I'll add 5 back to the array. Again, if there is another k, I have to delete the minimum, I have to delete the maximum, which are 2 and 5, and adding those will give us 7. So I'll add 7 back to the array. And it is also mentioned that it is also, in the constraints, it is also mentioned that the value of k will definitely be lesser than n. In that case, once we got a single element in the array, we won't be having any extra k's left. Okay, as simple as that. How do you solve this question? Okay, we are having t number of test cases. Out of that, we'll be having n and k array. Okay, fine. We have to okay, after processing that for k number of times, we should print the remaining array. Okay, very simple. So how do you do this? We'll consider the same 1 1 2 3 and 2, k as 2. Okay, 1 1 2 3. What we can simply do is we can just place 2 pointers over here. 2 pointers, or one variable pointer and one stable pointer. I'll tell you how. Okay, we'll keep one variable pointer p1. Okay, p1, and another stable pointer which is p2. Okay, now what I'm going to do here is, as long as my k is greater than 0, let's say we're at k equal to 1, where we have to do the first operation. What we'll simply do is we'll sum up the values. Let's say this is the current value which I have to add back to the array. That value is array of p1 plus array of p2. Okay, this point is clear, right? Okay, now the current value is array of p1 plus array of p2. Now I'll just move p1 pointer. Okay, I'll just move p1 pointer, and instead of decreasing p2 pointer, anyhow I am adding it back to the position of the p2. Okay, my updated p2 will hold the value current. Instead what I can simply do is I'll simply place array of p2 equal to current. Okay, this will now become 4. Understood this point? Now we'll do this operation while k not equal to 0. As long as k is not equal to 0, we'll decrement k after every operation and we'll do this. Okay, for the next operation, as we are incrementing p1 will be here. Now what do I do next? 1 plus 4, 5. So I'll update it to here, which is 1 2 5, and I'll also increment the p1 pointer, which is now 2 and 5. Okay, yeah, it is the Same as expected. Okay. Now the question is, what is the current array? What is the range of the current array? Very simple. It is simply the range of elements from P1 to P2 is nothing but representing the elements of the array. So we just have to iterate from P1 to P2 and print all the elements of array. That's it. Okay. I hope the logic is clear. If the logic is clear, you can start writing the code. Once it is done, you can come back to the video. Okay, we'll now start with the code. First the input format P. Okay, score in range of input. Now all I have to do is read two variables and k. Now I have to read an array equal to list of map input dot split. Okay, now I have to keep a pointer, a variable pointer at P1, I mean for P1, and a stable pointer which is P2 being assigned at n minus 1. Now, as long as k is not equal to 0, what I have to do? I should consider some current variable which is array of P1 plus array of P2. Now, this array of P2 should be assigned with the current, and then the variable pointer should be moved, which is P1. So P1 should be moved, and again, as we're done with an operation, we should decrement the value of k. That's it. And now we should keep on moving the P1 pointer, which represents the array elements, right? So simply print array of P1, comma, and equal to. And then after each test case, print an empty line. That's it. Okay, we'll submit. Time limit exceeded. Okay, what's the issue here? Okay, we are not moving the P1 pointer here. Understood. P1 plus equal to 1. Okay, now we'll run and submit. That's it. We'll move to the next one. We'll move on to the next question, which is equal pairs easy. Here, this is a kind of question which is interesting, and also it exists. There exists few edge cases which are easy to get. While implementing, you will anyhow get to know. You'll get to figure out the edge cases and all. Okay. Okay. We'll look at the question. So, for an array A containing non-negative integers, we define f of A as follows. Okay, for each index I such that A of I is 0, we should simply replace that AI by an arbitrary positive integer of your choice. Okay, we can assign array of I to any other random value. Okay, after doing that, we have to calculate the number of pairs I comma j such that I less than j and ai equal to aj. Okay. Huh. Then the distinct indices. Okay. Then f of a is the maximum possible value of p if you choose the replacements of the zeros appropriately. Okay. Okay. The question says that if I consider this case 1 1. Okay, 1 1 1 2 0 0. Now the thing here is you can choose the element 0. Okay, I can replace it with any other number, any other. Okay, I'll first explain you the first test case so that we can move to the second. Okay, 1 to 1, 3 3. Now the thing here is we are not having any zeros here. Then there is no modifications that should be done to this array. Now all I have to do is count the number of pairs, count the number of pairs I comma j such that I should be less than j, and again array of I must be equal to array of j. I should ensure all these cases. Okay, such way in such way I have these two elements common where I is less than j and a of I equal to a of j, and again these two elements common. Okay, now how many pairs do I got? I got this as a first pair and this as second pair, so the answer is 2 and I'll return 2. Okay, and I'll return 2. 2 is the expected answer here. Okay, next we'll move to the next test case where it is 1 1 1 2 0 0. Okay, now I can I can see that I have zeros here. What should I do now? What should I do? I should update this to some other random values. Okay, let's say I am assigning some 9 and 9. What's the answer now? This is one pair, this is one pair, answer is 2. But is that the case? In the problem statement, he mentioned that we should maximize the number of pairs that we can get overall. Okay, in that case, what do you understand? The value that you are going to update must be the maximum frequency that you got till now. Maximum frequency is having for ones. So the remaining zeros, I'll blindly update it with ones. That's the core logic here. Okay, this is the core logic here. Understand this point clearly. Okay, it is because only then we'll be able to form more and more pairs. Okay, it is this and this is one pair, this and this is another pair, this and this is one pair, this and this is another pair, and again this and this is another pair. Okay, okay, so how many pairs we got so far? How many pairs we got so far? Huh? So if we have 4, this will give us 2, this will give us 2, and next simply these two will give us one other pair. So overall I'll just give a this and this, this and this, 2 pairs, this and this and this, 2 pairs, this and this, 2 pairs. So overall we should get these many, and we miss the part which is this. Even these two can also pair up, which can give us 6. Okay, so the answer here is 6, which is same as expected. Okay, understand this point. Now if I have 1 1 1 1 overall, how many such pairs I can form? If the value of n is 4, can I simply say n into n minus 1 by 2? If this is the value of n, okay, it is simply n into n minus 1 by 2. Okay, why is that so? This one can pair up with all the remaining ones, which gives us 3 pairs. Okay, so 3 plus this one can pair up with these two ones, which is plus 2, plus this one can pair up with this one, which is 1. 3 plus 2 plus 1, which is nothing but, if this is n, if this is n, you have to find the first n minus 1 natural number sum. So what is natural number sum? N into n plus 1 by 2. But here n is now becoming n minus 1. In that case, the updated formula is n minus 1 into n by 2, which is same as the formula that we discussed previously, n into n minus 1 by 2. That's it. Now, the question here is, previously we had zeros, right? Previously we had zeros. Okay, previously we had zeros. Okay, we'll just keep this formula aside, n into n minus 1 by 2. Now, the moment when we had zeros over here, we are updating only to ones. Why not twos? We also have 2, right? Why not twos? This value n into n minus 1 by 2 will be maximized only when you pick the maximum frequency in the array. Maximum frequency in the existing array. Okay, this is the core point here. Okay, what if we update this with twos? What if we update this with twos? This and this is one pair. This, two pairs. Next, this is another pair, one pair. We only got four pairs. We only got four pairs, or even simpler, you can even tally it this way. Here, length of 1, 1, 2. I mean, the frequency of 1 is 2, which means 2 into 2 minus 1, 1 by 2, which is 1 plus 3. 3 into 3 minus 1, 2, 2 by 2. So, 3 over 4. But 4 is not the expected answer. It is 6. So, the observation here is, we must make the remaining zeros as ones. This is the most important step. We should know which element, uh, we should be able to know every time that 0 should be updated with the maximum frequency element. Okay, in that way we are proceeding further. So in that case, if we want to implement n into n minus 1 by 2, we are having 4 ones, for which 4 into 4 minus 1 by 2, which is 6, plus frequency of 2 is 1. So simply 1 into 1 minus 1, 0 by 2. So 0 into anything, 0. So 6 plus 0, overall answer is 6. That's it. Simple. Understood this point clearly? Now, how do you implement this? How do you implement this? I'll just write the pseudocode. I'll just write the pseudocode. Okay. Now, for every element, I want to keep track of the frequency, right? For which, what will I do? I'll consider some hash map of type integer, comma integer, equal to new hash map, and so on, something like that. Now, what will I do? I'll traverse through the array. For int I equal to 0, I less than n, I plus plus. First, if element is equal to 0, I'll initialize something like count here, or number of zeros, whatever. I'll just do count plus plus. Else I'll update the hash map. Okay, else I'll update the hash map. How do you update the hash map? If the element is present in hash map, you'll update the hash map count with +1. Hash map element count with +1. Else you'll place hash map of element with frequency 1. Okay, now we are done with the hash maps. Now what's the next step? What's the next step? Simply, let's say you're considering some array. Let's say you're considering some empty array. And in this, let's say array list. In fact, array list. Now, what am I going to do? What am I going to do? Whichever element frequency is not 2, okay, so, sorry, not 1, I'll just add it to the array. Okay, I'll just iterate through the keys of hash map for int element in hm.keyset. What will I do? If hm.get of element is not equal to 1, then I can simply add it to my array. What will I add? Will I add the element or will I add the frequency of it? I'll add the frequency. All I need is the frequency, right? I'll add the frequency. Now, let's say after adding, I got the array something like, first I'll tell you the hash map for the second test case, which is 11200. Now, what will I do? 1's frequency is 2 and 2's frequency is 1. And in the hash map, the only element which is having the frequency other than 1 is the element 1. Okay, so I'll just have array, the updated array as 2, where this 2 representing the frequency. Okay, this is just a comment. Okay, now I'm also having the count, right? Count. Now, what do you mean by this? I'll simply do n into n minus 1 by 2 and I'll simply say my array of 0 plus equal to count. What's the reason? Why am I doing this? Why am I doing this? I told you the reason. Every time to maximize the value of n into n minus 1 by 2, you should maximize it to the maximum element, of the array. Here we have a single element, so we are directly assigning it. But can we do that? No, no. So instead, what we are supposed to do? So you have to write something like array dot sort, array dot. I'm just writing the pseudocode. Array dot reverse sort, which will help you get the descending order. So the first element in the array is now the maximum element. Now for that maximum element, I'm adding count to it. And now I'll just consider some answer equal to 0. I'll just iterate through the array for int element in array answer plus equal to n into n minus 1 by 2. That's it. At the end, print the answer. I gave you the rough pseudocode and there exists few edge cases in this code. What are all the possible edge cases here? Just think about it. Just think about it. Okay. The edge case is that when you consider the last test case, which is 0, 0, and 0. Now, we'll just simulate the code here. If the element is 0, 0, 0, the count will be 3 and the hash map will remain empty. The hash map will remain empty. Now, as you are doing reverse sort, array will remain empty, but you are doing array of 0 plus equal to count. Okay. Now, what do you understand? What do you understand? If my length of array is 0, if it is 0, then what will I do? I'll add count to it. Instead of updating array of 0 to this, what will I do? I'll first check this condition. Else I'll do this. Okay, I'll just write it properly. Okay, so the case here is if my length of array is equal to 0, then I'll add count, else I'll do this. Now do you think all the hidden or edge cases are now passing? Think about it. There is one other edge case. Just think about it. Pause the screen. Just think about it. Try multiple edge cases. See it with some various inputs. Just think. See if you can get an edge case with this code. Okay, there exists an edge case. So what is it? Simply, when your test case is when your test case is 1 comma 0. Okay, so what's the manual answer for this test case? You'll simply update this 0 to 1 and the manual answer is 1. And you're obviously having one pair. Okay, the manual answer is this for sure. Now we'll simulate the logic. Count is 1, count is 1, and again hash map will be this. And again, in array, what are you appending? In array, what are you appending? 1. If it is not 1, you are appending. If it is not 1, you are appending. Okay. If it is not 1, you are appending, right? So how do you handle this? The array will remain empty. So as the array is empty, you are adding count to it. So it means you'll get this. But at the end, what's the result? You're iterating through the array element into element minus 1 by 2. So 1 into 0 by 2. 0 into anything? 0. So it will return you 0. But the expected is 1. How do you handle this? Simply, if my length of array is 0, and again, inside this, you should check. If my count is equal to n, what should I do? If I'm having all zeros, then I should add count. Else, what will I add? To handle this, what will I add? Simply array dot add count plus 1. That's it. We are done with the code. We have handled all the necessary edge cases. Okay, just go through the code once. Just go through the code. If the code is clear to you, you can start writing the code in the Codechef editor. You can submit it. Once done, you can come back to the solution. You can come back to the video again. Yeah. Okay, we are good to go. We'll discuss the code for this. So the input format, you have to read t, n, and array. That's it. Okay. So we'll do the same for underscore in range of int of input. Now I'll read an integer n equal to int of input, and array equal to list of map of int comma input dot split. And now I have to keep track of the number of zeros and the count of each and every element in a hash map. Okay, I'll use a hash map. I'll use some count variable to keep track of the number of zeros. Okay, for element in array, what will I do? I'll just traverse through the array. Okay, as we are using array there as well. Fine, we'll do this. Now, if element is equal to 0, what will I do? I'll increment the count. Else, what will I do? Else, I'll check if my element is present in hash map or not. If it is not present, hash map of element equal to 1. Else, hash map of element plus equal to 1. Now we are done with the hash map. We are done with the hash map. Now what's the next step? I have to consider some temporary array where I'm going to store all the frequencies in the hash map. Okay, let's say that is a temporary array. Now, now, what's the next step? What's the next step? I have to iterate through the keys of the hash map. For keys in the hash map, this element is representing the key in a hash map. If my hash map element frequency is greater than 1, then I'll simply add it to my temporary array. Okay, now we'll also parallelly handle all the edge cases where you have to sort the temporary array sorted of temp. Okay, as we're considering a reverse sorted, right? Okay, so reverse sort, we are sorting it and reversing it. Okay, and now we have to check if my length of temp, if this is equal to 0, then I'm having no elements at all. Now I have to check both the cases. If my count is not equal to n, what am I supposed to do? I'll simply append count plus 1 to the temporary. Else I'll append count to the temporary array. Now in the else part, what will I do? If the if the temporary array size is not 0, then I'll simply add count to it. Okay, now I'm done with the else part as well. Now I have to just iterate through the temporary array and get the answer. Let's say the answer is 0 for element in array. I mean, not array, temporary array. Answer plus equal to el element into element minus 1 by 2. Okay, and then you will simply print the answer. That's it. Okay, temp is not defined. Okay, temp dot append element. Okay, spelling mistake. My bad. Hmm. Output should be 263. Yeah, we got it. We'll submit it. Yeah, that's it. We'll quickly move to the next one. So moving to the next problem, equal pace hack. So compared to the previous problem, this is just some advanced variation of that. Okay, we'll see the problem. Previously, the n was smaller, but here we have n equal to 2 into 10 power 5. So now, uh, for this problem, everything is same except there is a condition given that initially all the elements of A filled with zeros. Okay, and the only thing here is if you have n equal to 4, then it simply means you have initially four zeros, and for every query 3 comma 2, which means you should go to index 3, 1, 2, 3, and 4. You should go to index 3 and make it 2. Hmm. And make the element 2. Make the element that you have here as 2. Now what's the answer? What's the answer as in? What's the number of distinct pairs I comma j, I less than j, and a of I equal to a of j? To do this, before we have to update zeros with some random numbers and should maximize the value that we can. maximize the number of pairs that we can. Okay, so how do you update the remaining values with 2, 2, 2? So we have 4 2's, so the answer will be 4 into 3 by 2, which is 6. Okay, so you are printing 6 here. Clear with this point? Next. Now we'll move to the next query, which is 1 comma 1, which is 1 comma 1. With this 1 comma 1, we'll go to index 1 and we'll update the value here with 1. Okay. Now what's the value? What's the answer? Either you can convert the remaining zeros with ones or with twos. Anything is fine. We'll go with twos. What's the answer now? We have 3 twos. 3 twos as in 3 into 3 minus 1, 2 by 2. So 3 plus number of ones is just 1. So 1 into 0 by 2, 0. So 3. So here printing 3. Next query is 4 comma 1. If you have 4 comma 1, simply go to index 4 and update the value with 1. Now what should be the value that you should update here 0 with? Obviously 1, it is because the maximum frequency is 1. So it is now clear that we should also keep track of the maximum values that you got till now. Okay, which is 1. And now the answer is 3 into 3 minus 1, 2 by 2, which is 3. Which is what we have here. And next, go to index 2 and update the value with 4. Now what's the answer? We have 2 ones, so 2 into 2 minus 1, which is 1, by 2, which is 1. And 4 frequency is 1, so 1 into 1 minus 0, 0 into anything, 0. Next, again for this, 0. So overall 1. That's how we got 6, 3, 3, 1. Okay, now the brute force implementation is something which is very much easy, but look at the constraints. Look at the constraints. T is 10 power 4, N is 10 power 5, and obviously sum of N over all the test cases will not exceed 2 into 10 power 5. Now, how do you solve this? How do you solve this? How do you solve this? See, it is very clear that you have to carry forward the answer. That is the most important point here. That's the core logic here. Okay, so the moment when you have all zeros here, the first query was to update this with 2, right? And remaining all were zeros. The thing here is, at any point in time, you have to calculate you should be able to keep track of the maximum frequency of an element plus combining these three. Combining these three will help you get the answer. But again, at some point in time, let's say you have something like this: 2, 2, 3, 2, and the number of zeros, let's say count is equal to some 3. Okay, at this point we had this, and what's the next step? If the next query as well, let's say is 3, then what are all the modifications that you are supposed to do? This will become 3 and this will become 2. But before doing that, what was the previous state? 2 and 2, 3 and 2, count is equal to 3. The answer associated with this and this should be reduced. As in, how much you should reduce? How much you should reduce? Simply minus count plus maximum, which is 5. 5 into 5 minus 1, 4 by 2. This much you should reduce. And the incoming is this, 3. So 3 plus 5, 3 plus 2, 5. Again, plus 5 into 4 by 2. This way you have to do it. Okay. As it is for the this part consideration. But there may be a case where you might have considered this part instead for the answer. In that case, how will you update it? Okay, what I'm saying is, if this is the part that you are working on till now, Maxi was pointing to this, then what's the answer? What was the answer? You'll have something like this will form one pair, and this 5 into 4 by 2, which is 10. Okay, this and this will form 10 pairs. Now, if the incoming query is 3, you have to increase this, which is this. Okay, before moving from here to here, there are few things that you need to understand. Here the answer is 11. That's for sure. But while moving from here to here, what do you understand? What do you understand? 1 0 is being reduced, as in how much exactly your answer is getting affected with? How much? See, if I have something like 2 2 0 0 0, this 0 is pairing up with this 2, this 0 is being pairing up with this 2 to get a pair, to form a pair. Again, the same way, this and this. Again, this and this. Now, ultimately, if this 0 is getting reduced, then you should also reduce the number of pairs that got affected here, which is nothing but the maxi that you kept track. So, you must always do the maxi. Okay, you must always keep track of this for sure. And then add the existing, delete the, add the existing part and delete the outgoing part. That is the most important step here. If you can handle that part, then the entire code as well is done. Okay, I'll tell you how. I'll give you the pseudocode. So what you're going to do here, you'll consider some, initially all are zeros in the array. So I'll just say count equal to n. The number of zeros in the array are n. Now I'll keep track of the maximum and minimum. Not minimum. I'll keep track of the answer this way. Okay. Now, what will I do? I'll loop over and I'll read x comma y, right? And that x comma y is nothing but the um, this is pointing to the index, and this is the value which we are placing. This is nothing but array of index. Okay. Now, what's the next step? We should check first if my y is present in hash map or not. If my y is in the hash map, I'll update the hash map of y frequency, else I'll place hash map of frequency, hash map of element with a frequency 1. Now what's the next step? As I'm converting one, as I'm reducing a 0, what will I have to do? I'll simply do count minus minus. Okay. And also, as I'm doing this, before doing this, I can update the answer as, or even if I update the count as I'm having the incoming element, the answer will be updated with hash map of y minus 1. And after that, you should also update the maximum frequency that you got. So what is the maximum frequency? Simply the max of maximum comma the current element frequency, which is hash map of y, hm.get y. Now what's the next step? For this query, I have to update the incoming and outgoing part. How will I do that? I'll just say for current query now equal to answer. What I have to subtract? As mentioned, the maximum whichever I got will be subtracted. Maxi into maxi minus 1 by 2. And what's the update? What's the value that is getting updated? Some maximum plus number of zeros is being updated. Let's just say that is some current which is maximum plus number of zeros. So this is now getting multiplied, which is current into current minus 1 by 2, and for every query you'll just print this value now. That's it. Okay. Now if you understood the logic, okay, the main thing about the code is understanding how these operations are getting executed. So just consider various test cases. You'll understand this. From one query to one query, answer is getting updated in this way. The maximum is getting updated, the number of zeros is getting updated. So we'll just carry forward the same values. That's it. Okay. Now, just pause the video, execute the code in the Codechef ID, submit it. Once done, again come back to the video. Okay, we'll start with the code. First the input t, and then foreign range of input. What are we supposed to do? We have to read an integer n, and then the number of zeros is equal to n, and now I have to initialize my answer with 0, and I have to initialize my hash map. And then what's the next step? I should also consider the maximum value that I have. Maxi is also 0. Now I should simply loop over the number of queries, which are n, and now I have to read the values x and y. X comma y equal to map of int comma input dot split. Now I have to check if my y is in hash map of y plus equal to 1, else I'll update my hash map frequency with 1 if it is not present. Okay. Now, now as 10 is getting reduced for every query, what I'll do is simply just do count minus minus. Now, what's the next step? As mentioned, answer will be now updated to hash map of y minus 1. This is what we are discussing previously, right? It is because if we are having 1 1 triple 0 or 1 1 triple 0. See, if this is the case, 1 1 0 0 0, if this one is the query that you wanted to add, what do you mean by that? This one is being paired up with these two ones. Okay, this one is being paired up with these two ones. Okay, for that reason I'm writing it as hash map of y minus 1. Now what's the next step? I'll have to update the maximum. Maximum is simply the maximum of maximum comma hash map of y. Now this is the updated maximum. Now I have to get the answer for the current query, which is, let's say, now equal to answer. And now what's the outgoing answer? Is simply maxi into maxi minus 1 by 2, and again what is getting added? Maximum plus 0 is getting added, right? So I'll add it to the answer, which is current into current minus 1 by 2. That's it. And for each query, I'll print the current answer, which is now, and I'll come out of the for loop and I'll just print the answer. Okay, we'll just see. Okay, 0 is no, okay. We're making use of count variable, right, for zeros. Okay, we'll run the code. It should give us 6331 and yeah, it's working. We'll submit it. It should work. Yeah. So that's it for the video, guys. Hope you like the questions, explanations, and everything so far that we discussed in the video. Also, share the video editorial solutions to your friends. And don't forget to hit the like, share, and subscribe button. And apart from this, not only the contest solutions we discuss, we do teach the entire DSA course from RN. If you are really interested in mastering the DSA, cracking the top product based companies, then you are hitting the right resource. So I'll just share the course details in the video description. Do refer it. So yeah, overall, thanks for watching the video, guys. Meet you all in the next video.